Welcome back to geometry. Hope you've had a good spring break, and we are going to have our quiz for all of chapter 10 this Wednesday. But that will allow us 3 days, I'm including Wednesday as a day, Monday, Tuesday, and Wednesday, to discuss during the office hours, or what some are calling immediate response time, to discuss the review, to discuss the practice quiz I'm going to post shortly, and even this video, or probably will be videos. So I'm going to go over these 6 topics. You might recall we skipped 10.5, that's why that's not there. Also in 10.2, you might note that I have decided to omit the what was it again? Kites or rhombuses. No rhombuses or kites. So that, I'm not even going to mention what the formula was, will not be on this quiz. And this is a quiz. I think I'm going to call them quizzes for the rest of the year. We'll do a chapter 10, 11, 12. We're just going to have them as quizzes in this format. So let's go over these things. We'll do 10.1, 10.2, 10.3, and then take a break and do another video with 10.4, 10.6, 10.7. So starting off with the area of parallelograms, rectangles, and squares. So let's say this is 5 inches, this is 3, that there is 2 inches. Over here we have, this is 5 feet, and this is 2 feet and 2 feet. And then this is our square, and so we'll say every side is 2 on this one. So if I want to find the areas of these, the first one, called shape 1, would just be 5 times 2, because it's base times height. For all of these, the reason I'm grouping these together, these are all base times height. And when you hear base times height, it's always distances that are perpendicular to one another. So notice perpendicular, perpendicular, perpendicular. So there we go, base times height. This one would also be 5 times 2. Remember, to get credit, you have to show your setup, your answer, 10, 10, and this is before. And what's the other one? Units. That's right, units. So this would be square feet. And this, they didn't give units, so let's say units squared. So that is not so bad. Areas base times height. Triangles. There's 2 kinds of triangles we might encounter. A right triangle and a triangle that's not necessarily right. Let's say this one is 5 and 6. And technically, if you want to know what this is, what is it? Square root of 61. You could check me on that. This one we'll just say is 8, 10. Call this 6. We'll call this 12. This may not even be possible, but that's okay. So the area of a triangle, remember what that is? Give you some thinking time. It's close. It's got a B and an H in it, but it's 1/2 BH, or BH divided by 2. So 1/2, on this one, the base and height have to be perpendicular. And you see, there we go, perpendicular, there we go, perpendicular. So this is 6 times 5. This one is 12, whoops, forgot my half, 12 times 6. So this first one is 15, I didn't give any units here, let's just make up some units. Millimeters squared, we'll call this A4, just so that they're not getting the areas mixed up, A5. This one is 36, and make some units on this one, inches squared. that's 10.1. It's just area. Area is base times height. If it's a triangle, it's half base times height. Okay, 10.2 and 10.3 are quick. Let's mix it up, do a little green here. So 10.2 is area of trapezoids. As I said, we are not even going to do kites or rhombuses. So let's say we got a trapezoid here. I mean, this is 8 feet, and this is 20 feet. And I can make up stuff here, but it doesn't really matter if that's 6 and this is 11. But what we need is we always need perpendicular distances. Let's call that 4 feet. Get out of here. 4 feet. So remember what the area of a trapezoid is? Area, trapezoid. This is one of the things that I say surprises me how much it comes up on the ACT. It is the average of the bases times the height. Hey. I don't know if that kept going or not. Average of bases times the height. Sorry about that. So the average of our bases is the sum of the bases divided by 2. And the height, of course, is the distance, the perpendicular distance between the height. Oh, I gotta see if it'll let me do this again. There we go. That perpendicular distance between the height. So this turns out to be, what is that, 14 times 4, which is, I don't have a calculator here, but we know this is 56, right? 56 square feet. That's it. That's what 10.2 is. Area of trapezoids. You must have the bases and the height. The bases are the parallel sides. The height is the distance between the parallel sides. You could have a trapezoid on its side, and that'd be fine. That just means your height would actually be a horizontal measure. Okay, let's do one more and then we'll take a break. Let's do area of equilateral triangles. So if you have an equilateral triangle, remember all the angles are 60, and let's just say all the sides here are 8 meters. Just mark them like that, so all the same. So remember the area for an equilateral triangle? Equilateral triangle. It is square root of 3 over 4 times the side length squared. This is not in your book, I don't think. But we derived in class by drawing an altitude and doing all that 30, 60, 90 stuff, and we don't want to do it again. We have the formula now. Let's use it. So in this one, it's simply square root of 3 over 4 times 8 squared. And I picked some good numbers because 8 squared is 64, and 64 is divisible by 4. 64 over 4 is 16. So this is just 16 square root of 3 square meters. And you know, if we are not doing a word problem where they tell you to round to something, it's better to leave it in radical form. So one thing, I mentioned area of equilateral triangle and regular hexagon. The reason those go together, by the way, if I'm going too fast, you can pause me. If I'm going too slow, you can speed me up, and nothing wrong with that. Hopefully the product you're using will allow you to speed me up. Lastly, as I said, switch again here to, let's go to black. A regular hexagon. The reason this fits nicely is because a regular hexagon, if you draw the diagonals in, remember what happens? Wow, that's pretty good. It creates 6 triangles, and all the triangles are congruent. All of these diagonal pieces are congruent. All of these angles are congruent. So all of those angles are 60. And looking at this triangle here, since these sides are the same, it's equilateral, so therefore this must be the same as this. Well, what two angles add to, since that's 60, there's 120 left for those two. These also have to be 60. What do you know? We got an equilateral. You don't have to do that. You should just probably memorize the way that works. So the area of a regular hexagon is actually equal to 6 times the area of an equilateral triangle. So if you know that formula from up here, it's just 6 of those. So let's say I tell you that this is 5 inches. Then you just say, okay. Now this time I did not pick a real nice number. 6 times the square root of 3 over 4, 5 times 5 squared. I could simplify this if you want. That's 3 over 2, right? 6/4 is 3 over 2. So we end up with 3 times square root of 3 times 25 over 2 square inches. And yet 3 times 25 is 75. So this is 75 square root of 3 over 2 square inches. That's the area of the regular hexagon. And that's the first 3 sections, just a flyby. You're doing a review in the book, you're doing practice quiz. We're going to talk about those things. We'll talk about any of this. I actually made all of these on the spot, so I might have made a mistake. We can talk about that at those office hour times, which is 2 o'clock, Monday, Tuesday, Wednesday. I might have to move the Tuesday one. I'll get to you. I'll make sure on Monday to tell you about that. But I will see you next time. Thanks for listening.